Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. For us to create the largest number, we need to pick the biggest digits for the start of the number. So the biggest digit is 7, then 6, then 4, then 3. But the question says it wants the largest even number, so we need to just swap the last two around to make sure that it is even. So our answer is 7,634. So we can either use the calculator to work out what 1.2 cubed is, or we can do 1.2 times 1.2 times 1.2. Now if you want to use the calculator to go straight there, you're going to press or type in 1.2, and then normally there's a button that looks like this, X with a little 3, okay, and that will give you the answer. Or if you're not sure how to do that, you can times it by itself 3 times, and you get the answer 1.728. So what we need to do is find out where the graph is at its highest, and so it's highest here. And so if we go down from there, we find out what year it is. Well, these years seem to be going up in 1, so that's 1950, 1951, 1952. So the answer would be 1952. To answer this question, we need to cut this shape into two shapes. So we're going to draw a line across here, and we're going to cut it into a rectangle and a triangle. Now we need to first of all label the parts of the triangle. So the length or the width of the triangle, the base, will be the same as the base at the bottom, so that will be 20 centimeters. And we need to find the height, which is this length here, which is 90 degrees to the base. And to find that, what we can look at is the fact that the total height of the whole thing is 13, and the height of the bit we don't want is 11. So what's left over? Well, 2 centimeters will be left over, so the height will be 2 centimeters of the triangle. So let's work out the area of the triangle first. Which is going to be half times base times height. Half times the base, which is 20, times the height, which is 2, will just give us 20. Now let's work out the area of the rectangle. And that's just going to be the width times the length. Width is 20. The length is 11, so that would be 220. Then to work out the total area of the whole thing, we're just going to add those together. So 220 plus 20, which is 240. The units are all in centimeters, and so the area units will be centimeters squared. So we have an original amount, and this represents 100% of the original amount. The new price, new amount, represents 113% because it has said that it has gone up by 13%. So it has increased by 13%. And as a value, that increase is £1,287. So it's 13% of the original. It's gone up 13% of the original price. So what we're going to do is we're going to work out what 1% of the price increase is. Instead of 13%, we're going to work out what 1% is. And we're going to do that by dividing the amount by 13, and we get 99. So 1% represents £99, so 1% of the original represents £99. But the new amount is 113%, so we need to times the £99 by 113, which gives us £11,187. So the picture is now worth £11,187. The midpoint of a line is the halfway point, and we can see that it is roughly here. And there's a couple of different ways we can work this out. Either we can just look at the graph and just kind of try and work it out that way, or we can use the equation. Now the equation is, to find the midpoint for the x, what we do is we add the two x coordinates together and we divide by 2. And so the x coordinate of A is 3, and at B it's 0. It's going to be 3 plus 0 divided by 2, which is 1.5, 1.5. So we know that's going to be 1.5. I'm going to do the y a slightly different way, maybe. We've gone from -3 to 2, and so we can just look at the fact that the halfway point here is going to be at -0.5. That's going to be -0.5. If you didn't really see that, we can use the equation. The equation's simple because it's just y1 plus y2 divided by 2. And so the y coordinates are 2 and -3. 2 plus -3 is just going to be -1. -1 over 2 is just going to be -0.5. Whenever you have angles on parallel lines, you always draw out the letter in which they create. So we could have a situation here where the two angles create a Z like this, and those will be alternate. They could create a Z like this. That would also be alternate. They could create a C, which looks like that, and that would be interior, co-interior, or allied, depending on your preference. There could be a backward C, again that would be interior, co-interior, allied. Or they could look like an F. Now there are several Fs, about 4 Fs that they could look like. There's the F like this. There's the same thing but backwards. And there's the upside down versions. So you have the ones that go out this way. And the actual one we've got here, if I don't move that, the actual one we've got here which goes inwards like that. Seem to be moving things. Let's try that again. So with all the F angles, we know that they're corresponding. Now, how do we figure that out? How do we remember that? There's loads of different ways. The way I remember it is I remember corresponding for corresponding. I remember alternate for alternate, and then either co-interior, interior, allied, I just remember as the other one. So interior, I just remember as the kind of C one, the other one. And so with this question, we've got x is equal to 73 because of F angles, and I just remember corresponding. So the word I write down isn't obviously corresponding, but corresponding. And it sounds silly, but I've remembered that for all my years teaching. I used to get corresponding and alternate mixed up. That was the way I remembered it, and I've never had an issue with corresponding alternate angles again. So whatever method you have, just to help you remember which one to pick, obviously have a method in advance of the exam, and then when this question comes up, you'll be more than happy to pick the right one. Here we're given two angles on parallel lines, and the parallel lines are here and here. And if we draw the line that they are on, then it creates a little C shape. Now, whenever we were dealing with C angles, we call them either interior, co-interior, or allied angles. And what we know about interior angles, I'm just going to call them, is that they add up to 180. So we can get that 20x, and we can add to the 40x, and we know that that equals 180 degrees. And I need to make sure I write down the reason, because they're interior angles. So here I'm going to be solving this algebra. I'm just getting my tramlines in. 20x plus 40x is 60x equals 180. And we're going to divide both sides by 60 to get x on its own. So we can solve it. And we've got x equals 3. So the value of x will be 3. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got well, we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135. And the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225. And so our answer is 225. So we're going to write out the question again, just to give us a bit more space. And we're going to put in our tramlines so we can solve it. Now we're going to solve this in exactly the same way as if it was an equation with an equals in the middle. One slight difference though is if you times or divide by a negative, you've got to flip the sign, but hopefully we won't do that. Now the rule when you've got an x's on both sides is you get rid of the smaller amount. So we're going to get rid of that 4x from both sides. So we're going to take away 4x both sides. And so we're going to have 3x plus 8 is greater than 23. And then we're just going to solve this normally. So take away 8 both sides. And that will give us 3x is greater than 15. And then we're going to divide the 3 both sides. And that will be x is greater than 5. The formula for an exterior angle for a regular polygon is 360 divided by the amount of sides. Now here we're given the fact that the exterior angle is 30 and we're looking for n, so we just need to rearrange the equation. We can times both sides by n. And then divide both sides by 30. And so we've got n equals 360 divided by 30. And when you do 360 divided by 30, we get the answer of 12. So it's a 12-sided shape. Okay, let's just do a quick sketch of the graph. And we've got coordinate C is at 213, so we're going to say that's roughly there. And that's C, and that's at 213. And then we've got D, which is at coordinates 8, 4. And we're just asked to find the length of the line segment, so this length here. Now what I can do is I can draw in a right angle triangle here, like so, and we've got the right angle there. And we actually know two of the lengths, so if it's 13 high for C and then 4 high for D, that means that this length here is going to be 9. The x coordinates are 2 to 8, and so that's a difference of 6. So, and we're looking for the last one. So with Pythagoras, we are going to label the sides, and so we've got A here, we've got B here, and then C has to be the one opposite the right angle. And we're just going to write out the formula, which is a squared plus b squared equals c squared. And A we've said is 9, and B we've said is 6. And so when you do that, you get, what, 117. Then we're going to just quickly solve it by square rooting both sides. And so we're going to square root 117, which is 10.816 blah blah blah. And it says it wants 2 decimal places, so our answer will be 10.82. So for us to work out the average speed, so we've got to first of all remember the triangle. So average speed is total distance over total time. And we're told to find the average speed before stopping. So stopping is shown with a horizontal line on a distance time graph, so it's up to this point here. So the average speed will be the total distance, which would be 20, over the total time. So 9:30 to 10 will be 30 minutes, but since our unit will be kilometers per hour, we need that in hours, which will be a half. And 20 divided by a half is going to be 40. So our answer is going to be 40 kilometers per hour. With this question, you've just got to know what the different functions look like. So with C and D, we've got quadratic functions. One's a positive quadratic, which is a U shape. One's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that, so we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A. First thing I'm going to do is add these column vectors. So we're going to add the tops first. And then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4. And 11 take away 14 is minus 3. Then I go pick a point on my shape. And the bottom or the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. So this says find the probability of A or B. Now A or B means it can be in A, it can be in B, or it can be in both. So we add the 5, the 3 and the 12 together, and that gives us 20, and put that over the total amount. So that is these 3 added together, which is 20, plus the one outside here, which is 30. 20 over 30 is the same as 2 over 3. With these questions, it's normally easier to view these as 2 separate triangles. So we've got a small triangle here with 19 and 47. And what I'm going to do is I'm just going to move this out. And we've got a bigger triangle here. And we've got Well, we've got a bit of, we don't really know what any of the sides are just yet, but we can work them out. Okay, now we know that both of these triangles are similar, and the reason is they share an angle and the lengths at the bottom are parallel, so they will be similar, which means one's an enlargement of the other. And we are given some information in the question that the ratio of BC to DE is 1 to 6. So BC is this length here, and DE is this length here. So we're actually given the scale factor because we know that 1 times 6 is 6. So we know the scale factor is 6, and it's asking us to find length AD. And so the corresponding length to AD, which is this one here. So all we need to do is get that 47, times it by the scale factor, so times it by 6 to get to our value. So it's 282. So what I'm going to do is work out how I get from my centre of enlargement to each of the vertices on our shape. And so I'm going to pick the bottom left one first. So we go 1, 2, 3, 4, 5, 6 jumps to the left. Now with a scale factor of 1/3, instead of 6 jumps to the left, it's going to be 1/3 of that for our new image. So instead of 6 to the left, it's only going to be 2. So our new point will be here. And we're going to do the same to the top left one. This is going to take a bit of time, but that's fine. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So instead of 12 up, we're looking for our new one to be 1/3 of that, which would be 4. So 1, 2, 3, 4. So it would be on the x-axis. And we go 1, 2, 3, 4, 5, 6 to the left. And again, instead of 6 to the left, it's going to be 1/3 of that, which would be 2. So our new point will be here. And so if we draw in the new shape, let's make sure we try and do it as neat as possible, then it will be this bit here. It says to label it B, so we'll put a B on it. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.